Yes, as always, the only favor that you can do to us is to subscribe to Kenya Science Academy. Back with grade 8 integrated science. Now, the last time we met, we talked about temporary physical changes. And in that case, I gave an example of heating a candle wax. Remember, a candle wax is solid in nature. When you heat a candle wax, it turns to liquid state. How about when this liquid state is cooled? When the liquid state is cooled, it goes back to solid state. That tells you that it is a temporary change. It changes back. Any change that goes back to its original state, that particular change is temporary. It is temporary. It does not exist in its own state forever. But after some times, it goes back to original state when you do 1, 2, 3 manipulation onto it. So such changes are temporary. And remember, physical, something that can be seen as the heat happens. But in this case, we want to talk about chemical changes. So there must be involvement of chemicals. So there must be some chemicals accrued in this particular change to testify that indeed this is a chemical change. So there must be some chemicals. Now, there are certain chemicals that changes in terms of color. Remember, I talked about these changes can be in terms of color, can be in terms of state, in terms of appearance. So those are some of the characteristics of something that has changed. And in this case of chemicals, we are going to see whether there is a color that has changed, whether there is a new substance that has been formed. Remember, there are some substances that are formed along the way. During chemical reactions, chemicals react. And when they react, there are new substances being formed. That is chemical change. Chemical change. Now, these are the things we want to look at. Is there color change? Can the color be taken from its original state to another new state? And when we get that new state, can we take it back to its original state? So in that phenomena, we call it reversible. When a particular substance moves from its original state and changes to a new state, and from its new state to its original state, that particular phenomena is called a reversible change. So chemicals also do behave in that manner. And there are other chemicals that whether you do what unto them, they will stick to their colors. They will. So that is permanent. That is something permanent. So that is something permanent. Remember to get the difference. Now, in temporary physical, there are changes that we see them as they happen. In temporary chemicals, there is involvement of chemicals in this particular change. And whatever that happened to the temporary physical changes, at some point unto chemicals, they also do happen. That is why we call it temporary. They are reversible. They can be taken to from the original state to another state, and from that new state to original state back. Hope understood. Now, temporary chemical changes. These are changes in which there is formation of a new substance, there is change in mass, and they are reversible. So we can say temporary changes. Temporary chemical changes or chemical temporary changes still means the same. Temporary chemical changes are changes in which, are changes that are reversible, new substances formed, there is change in mass, and heat is absorbed or evolved. Heat is absorbed or evolved. Look at the characteristics. These are the characteristics of temporary chemical changes. This is how they are. These are the features of such changes. What are the features? What are the characteristics? Number one, they are changes that are reversible. It means they can be taken to another state and from that new state to original state back. And then there is a formation of a new substance. There is change in mass and heat is involved or evolved and absorbed in this particular change. Now, for example of changes. So we have number one, heating blue hydrated copper 2 sulfate. Good, heating blue hydrated copper 2 sulfate. Now, we have a chemical in the laboratory. This chemical is referred to as copper 2 sulfate. It means there is copper, there is sulfur, and there is oxygen. These all elements, they make up a compound, remember, called copper 2 sulfate. Copper 2 sulfate. And copper 2 sulfate in symbol is capital C, small u, capital S, capital O, and some oxygen there. How many oxygens? 4. So you will be taught about naming of elements and their symbols. I will talk a bit of the first 20 elements of the periodic table here, and as well I'll teach you more in grade 9. A lot of it will be taught in grade 10 and above. Now, copper 2 sulfate has a symbol of copper. That is something that you need to know, sulfur and oxygen. And I told you that for you to succeed in science, you must know the first 20 elements of the periodic table. The first 20 elements of the periodic table, beginning from hydrogen, that is H, to calcium, that is capital C, small a. So make sure that as you learn science, integrated science, you well conversant with the first 20 elements of the periodic table, because it is from the first 20 elements that you will know these particular things I'm talking about. By now, we want to discuss about copper 2 sulfate as an example of a temporary chemical change. When you heat, it is blue when it is hydrated. And for that reason, I want us to know the following terms. the differences in the following terms. The differences in the following terms. I have said that number one example of a temporary chemical change is heating blue hydrated copper 2 sulfate. So it therefore means that copper 2 sulfate can be hydrated, and it can also be anhydrous. Now, meaning of hydrated. Hydrated means it has water of crystallization, or it contains water molecules. It has water molecules in it. So it therefore means that blue hydrated copper 2 sulfate has some water inside it already. It has water of crystallization. And in grade 7, remember you are taught about crystallization. And if you are not taught, please look for a video talking about separation of mixtures or substances in grade 7. Go and look for it. If it is not there, wait for it. It will drop very soon. So that is, crystallization is one of the methods where you separate a salt, the crystals of salt, from any mixture. So when there is salt, we can be able to crystallize them. Now, you remember, copper 2 sulfate is a salt. So this particular salt has some water. So the water inside it, when we call it hydrated, it means it has water. And that water is this part. You learn more about that. Don't worry. I told you, remember that copper 2 sulfate in symbol is this one. And when it has some water, the entire hydrated copper 2 sulfate is written this way in symbol. So you learn more about this one. Don't worry about this. It will come. So it therefore means that hydrated thing means it has a water of crystallization. It has some water molecules in it. So hydrated means water. That is why you say, I'm hydrated. You are anhydrous. So it means this one lacks water of crystallization. Yes, that is the difference between hydrated and anhydrous. Anything that is anhydrous, it means it lacks water. Anything that is hydrated means it has water. So in this case, when we heat hydrated copper 2 sulfate, this is called hydrated copper 2 sulfate. 2 in Roman numbers. 2 in Roman numbers. So this is blue in color. It is blue in color. So what happens when you heat this? So in that case, we must have an activity, practical and activity. Because in science, we do things we see things as we're doing, and we do them physically, and we get the answers just right with us. So we are going to demonstrate. So demonstrating how to heat, what happens, demonstrate what happens, demonstrating what happens when blue hydrated copper 2 sulfate is heated. Demonstrating what happens when blue copper 2 sulfate is heated, so that we can see and indeed testify that this change, referred to as temporary chemical change, has happened. So for us to know that a change has happened, we have to do an activity. Of course, how can I tell you that it is temporary chemical change minus seeing what is happening? So when you go back to your schools, try to liaise with your science teacher. Identify on how you can go to the lab, find a way on how you can go to the lab to demonstrate heating hydrated copper to sulfate. By now, I want to teach you what will happen, what is the procedure, what are the requirements, explanation of what happens, observation of what you're going to see, and how can we conclude about temporary chemical changes, about heating hydrated copper to sulfate. Now, demonstrating. And for us to demonstrate, there must be requirements. So, let us move to requirements. Requirements. Number one requirement, if you must have safety goggles. You must have gloves. Number three, you must have source of heat, because we are heating. In this case, I'm going to use Bunsen burner. Good. Number four. We must have a stand. We must have a stand because we are going to set up the apparatus, stand and a clamp. There must be cork. Cork. There must be delivery tube. There must be two test tubes. So we're going to have two test tubes. And another thing, we are going to have 250 ml beaker. For this our experiment, we must have some water in the beaker. Not water, sorry. So we have beaker, we have test tube, we have delivery tube, we have, what else? So source of heat, yes. So these are some of the requirements that we're going to have in this particular activity. And the reagent, which I was forgetting because that is the main activity. So in this case, let us use approximately 5 grams of blue hydrated copper 2 sulfate. Let us use 5 grams. So copper 2 sulfate hydrated, 5 grams, 5G. Yes, these are the requirements. Now, after that, we're going to procedure. Let us see our procedure. What is our procedure? So you can have a spatula spoon for scooping as another requirement because we are going to pick the 5 grams from the container holding it. So what are we going to say? The procedure. Now, we have 2 procedures. Number 1, so scoop 5 grams of blue hydrated copper 2 sulfate into one of the test tube.